How's it going, Precalc kids? This is 3.1a. We're going to look at exponential logistic functions. This is actually some of my favorite stuff. And you can say, Miss Twilly, you're nuts. And you're probably right. Exponential functions, what are they? Okay. Here's the Mr. Twilliger noteworthy definition. An exponential function has some a times bx where let's write it a little bit lazy. Where this stuff, a can't be 0. If it's 0, the whole thing can be 0. B is positive, not equal to 1. A is the initial value when x is 0. So it's b is 0. Well, it's 1. Sorry, I'm breaking stuff. And b is the base. B base, a initial, well, x is going to change. Okay? So when x is 0, your y is going to equal a. I'll give you a second to write down this stuff. Well, I got a piece of sports trivia for you. Who is the only player in baseball history to hit over 150 home runs, right-handed and left-handed? Think about it. Scrolling. Alright, are these exponential? If yes, identify initial value and base. A, 4 to the x. Well, we're taking it to the x power, so yes. Our initial, remember, is a times b of x. We don't have an initial. So our initial value equals 1. Right? That's our a. Our a is going to be 1 because it's 1 times 4 to the x. Okay. What's our base? Well, our base is our b, which is 4. Okay? And there we go. Okay, let's take a look at b. We have 6 times x to a third. Is this exponential? No. This has to be taken to the x power for it to be exponential. Now if I would write 3 to the x, that'd be yes. But it's not. So it's not, because you're taking it to third. This one then is going to be yes. Our initial value is 5. And our base, 3. Okay? Okay. Determine the exponential function of g and h whose values are given in the table below. Okay. So we have a table. Noteworthy, guys, sorry. It's going to take you all to write this. You guys can do it though, you're quick. Hit pause, write it, come back and watch me do the example, because if you're writing while I'm talking, it's kind of counterproductive. Okay, here's my hint. See this number here? You're timesing by 3 each time. What you're timesing by is your base. So I know it's going to be 3 to the x. Okay? Now you look for your 0. What are you at 0? That gives you your initial. Well, we're at 4. So that's our function. 4 times 3 to the x. Now for h of x. We can start with this. What's our initial? 8. 8 times. What are we going up by each time? 1/4. There we go. That's all there is to it. You take what you're going up by each time, what you're multiplying it by each time, take it to the x. Look at when x is 0 for your initial. Here we go. Okay, exponential growth and decay. So what it basically says, here's the Mr. T noteworthy version. You're not gonna like this, but right here, if you have some a times b to the x, if your b is greater than 1, it's increasing, and it's called an exponential growth function, and that's a growth factor. If it's less than 1, it's a decay, and your b is a decay factor. So go ahead and take a moment and write this. We only have a graph to look at, okay? And after we're done looking at the graph, we'll call it good because you guys have done a lot of writing on this one. So again, b greater than 1, growth, b less than 1, decay. Remember, a has to be greater than 0, can't be negative. Let's look at the graph of b to the x. Yes. Run this down so you know what they look like. Pretty much what this says, if it's growth, if b is greater than 1, you pass through the point 0, 1 and the point 1b, and you keep going up and you keep going faster and faster and faster. Exponential growth. Okay? Now, if b is between 0 and 1, so it's a decay less than 1, you start high, you slowly come down. You still hit the point 0, 1, and you still hit the point 1b, but you're getting smaller and smaller and smaller. Those are your two graphs. Okay? So let's take a look at an example. Let's say you're transforming the graph of 2 to the x into the graph of 2 to the x minus 2. Well, 2 to the x, 2 is bigger than 1, so I know that it's a growth, so it's going to look like this. Right? And we have the point, what did I say this was, 0, 1, and I have the point 1, 2, right? So that's my b. 2 is my b, so I have the point 1, whatever my b is. So remember, when we have x minus 2, what do we do with those points? Well, minus means we move to the right 2. So that means we're going to have the point 3, 2 on here, and this becomes 2, 1, and I just draw my graph. Okay, so same stuff as before, just the 2 points you're going to move are that 0, 1 and the 1b. That's all there is to it, guys. Enjoy. Hey guys, I lied. One more quick example. We have another transformation. Remember, all examples are noteworthy. So we have our original graph, which is going to pass through the point 0, 1 and the point, well, 1, 2, right? Now here we have 2 to the x into the graph of 2 to the negative x. I want to do this as a quick review for you guys. Remember, if the negative sign's by the x, or if it's f of negative x, you reflect, okay, over your y-axis, right? Now if it's f of x, negative out in front, you're going to reflect over x-axis. So for this one, I reflect it over, it's negative x, so I'm going to reflect it over my x-axis. So I have the point 0, negative 1. and 1, -2. There we go. That's all there is to it. Now that's all there is to it.